Amazing! I can hardly believe it. You Wheatley sorted those flies out. Ah ha ha ha! The Baron Bird may have long ago played through their final ending, but nostalgic rhymes will echo through your head with this episode of Let's Blending! Let me put my mouse over there and show you what I've done. And sorry for this intro, it's weird. Anyway, as you can see, I have a whole bunch of characters that all look slightly different and slightly the same. And they're running at a pretty good frame rate, between 46 and 48 frames per second, with the rasterizer at, why me, between 69 and 70%. Animations holding steady between 20 and 22%, which is good, because there's 27 characters there. In fact, what I could do is go ahead, Shift D, Z, and play. Hey, there's double the characters, still at 38 frames per second. So, some interesting things to note. If you have objects parented to a specific bone, instead of animating with the bones, it does save frame rates. Also, if you use Blender's new level of detail, it also saves frame rates, but my level of detail character looks ugly, and it clips outside of the clothing. Now, I know that the clothing looks a bit sparse, but that's what I have to do to make them animate quickly. But basically, to get this much variety, I have 18 different characters. That's 4 races across 2 genders and 1 alternate. That's, 16 different characters. 4 and 4 is 8, 8 and 8 is 16, and I'm using the object color to change their fur color and the color of their clothing. Something to note, H, the key H as in habanero or hot, will hide stuff. Or I could have said as in hide. But if you don't know if you've hidden anything, press A to select everything and hit Alt and H, and it unhides everything that's hidden. Select the item, hit H, Alt Z to bring up the character's textures, and hit play. Play again, play again. I originally had it to where the clothing was just cloth, but I'm also putting in leather, chainmail, and steel plate, or iron plate. These here, the clothing, are parented to the bones. Now, when you have the skeleton, select the pose mode, select the object, select the specific bone, hit Control P, parent to bone. Now, something to note. Certain objects, like this hair, which doesn't have any depth, when you hit Control P and parent it to bone and start rotating, it does this nuisancey piece of crap. It is annoying. And you might be wondering, well, how do I fix that? Well, you hit Control P and you set the parent to object. And now it no longer does that. I don't know why it did that in the first place, but when you hit Control P, you have set parent to object, object, keep transform, armature deform. I don't know what that is. Oh, wait, yeah, I do. That allows the object to deform with the armature, and you can choose with empty groups, with envelope weights, and with automatic weights. The envelope weights and automatic weights create weights and groups and put vertices in the group, but it usually never gets it very accurate, but it's close. And that's if you want to animate the character with the bones. And then you have set parent to bone and bone relative. I'm not sure I think bone relative sets it relative to the skeleton, but I'm not sure. But bone sets it directly to the bone. But if you want to, you can set parent to object. That seems to be similar to set parent to bone. I'm not sure if it's better or worse, but in the case of 2D objects such as hair or capes that don't have any depth, you might want to set parent to object. Yes, you are learning a lot of tips. Some of them you may not have known. Some of them I didn't know. But we already have the character with an armature deform, and I already went through all of these vertices and made them the best they can be. And the character looks pretty good. The player mesh, I can't remember if it is male or female. I think it's female. I'm still not sure. Nope. Wait. No. I think it's male. That's horrible when you can't tell the male and female characters apart. But I do have it to where the clothing is slightly different. And the females have a slightly bigger bust size. Another thing I have is this belly bone. Yeah, for various reasons. So when you do parent your object to a bone to animate and deform, going to put your bone into your skeleton into object mode, put your mesh into mesh mode, hit tab, that puts it in its default state, and then you go to this little triangular thing. Looks kind of like the inverted thing on Brainiac, if you know who Brainiac is. And then you can hit A to deselect everything. Select one of these. Under vertex groups, I'm selecting NM head. I think that's Neko Many head. And you hit select to select them all, deselect to deselect them all. You can use assign to assign them, remove to remove them, and set the weight. I don't know why I'm going over all this basic stuff. This is a little bit more advanced tutorial series, but I thought I would. Everyone's like, get to the code on the right. I'll get there. And you have a modifier called armature. Now, you can apply it as a shape key. And if you've ever heard me talk about falsetto anims, the false animation, you can apply specific poses to a shape key. Then create various copies of that object. Then delete all but the shape key you want to keep. D. then you can leave all but the shape key you want to keep, and it'll hold that shape. Then you can just use different characters frozen in different poses, and then just swap through the meshes. This may or may not save you some frame rate, and it has very limited applications, but it is sometimes useful. If you delete this, you can use Add Modifier and find Armature under Deform, and then click here to choose the armature object. I only have one, because so far I only need one. Although I am probably going to create a secondary version for NPCs and a third version so that you can see what your character looks like in the menu. Now then, this pretty much changes each character to be different. I will be putting a lot of this into the global dictionary to save, but something to note. If you want to save a little bit of file size on your save file and save a bit of RAM, remember, numbers are smaller than strings. That's why for character colors here and the cloth colors here, I only have 10. That's 0 through 9 indices, indicators, yay. And I have a couple of alternates and the races and the genders. Instead of doing true, false for the genders and having a whole lot of if statements, I just did a list. Now, the reason why I have male and femme, cat, dog, fox, wolf, A, B, cloth, leather, male, plate, those are specifically created because I've named them specifically. This one's named Femme Cat A and Femme Cat B. If you can't really tell the difference, Femme Cat A is striped, Femme Cat B is kind of like a snow leopard. And then we have Femme Dog B, which looks like a mutt, and Femme Dog A, which is solid color. Femme Dog B is kind of like a spotted mutt thing. I have the same for the males, and for the different clothing, Femme Plate bottom, Femme Plate top. Yeah, look at that shininess. Without shading, these would look kind of ugly. Femme leather top, Femme leather bottom. I don't really care much for the male. Chainmail. And yes, I do have male top, just in case you were wondering. Okay, now, the colors don't have to be perfectly accurate. So, I entered into GIMP and found some good, nice colors. For the character colors, you don't have a whole lot of variety. I think that the olive green was kind of pushing it. I do have a Russian blue, a fire brick red. I have dark gray, the 333, gray, the 777, and the light gray or white, the D. For cloth colors, the black is the 444, the gray is the 888, and the white is the E. Hey, a trip to Triple E. I guess it's white there. Never mind. I'll stop. Anyway, or not. Basically this, tricolor, tri-hex. You give it a string with 3 characters, and it uses this hex dictionary string and gets the index. Okay, first we take the trihex and we make sure it's a string. We keep making sure it's a string because sometimes when you break it up, it may turn it into numbers, and some of these are actually numbers as strings. And I just want to make sure they don't inadvertently turn into numbers. Otherwise, I might get an error. And I'd like to avoid errors. So, we get the hex dictionary. The index of the hex dictionary that the trihex string index 0 is from. Basically, for 333, it would be 3. And we multiply it by 16, and we divide it by 255. Now, you might be wondering, well, some of these have 0. And 0 would be 0 divided by 255, which is 0. Thankfully, in Blender's Python, they have a way around 0 division, which is really lucky for me. Otherwise, I'd have to put an if statement in there. And then I'd have to do if int trihex 0 equals 0. It's just a pain. So I'm glad I did that. And we create the red, the green, and the blue. We just multiply it by 16 and divide by 255 because the colors are floats. So we're basically taking hexadecimal colors, getting the 3 main characters and then putting them together. Like, there's a color pink. It's F-A-C-A-D-E. I use it a lot. If you noticed, F-A-C-A-D-E. Okay, so if you get F, the C, and the D, that would be the trihex equivalent. Because those are the 3 main numbers. Those are the numbers that would be multiplied by 16. And for those of you who don't know what hexadecimal is, I hate to say Google it, but Google it. It's basically base 16. Like, most of you probably have 10 fingers on your hand. You know, if you're healthy, happy, and lucky. And basically hex is 16 characters. So you'd add an extra hand and a thumb. Actually, you don't have 10 fingers, you have 8 fingers and 2 thumbs for 10 digits. Never mind. And then we get red, green, and blue, and we create the color red, green, blue, and we put 1.0 as the alpha, because I could put, wait for it, 0.5. Let's show you this. Ghastly, isn't it? I know, I said I'd stop with the puns, but now, some of these don't have, well, some of the clothing areas and some of the areas of the character are set to a different material that ignores the object color. You can set materials to accept an object color, which is great. Now, here's something interesting. 5. Just because it has to be a float doesn't mean you can't have fun with it. Yes, you can oversoul or saturate colors. I could put the full 255 in there, in fact. Let's see what it does. Yeah, I know, I'm just playing around. But you guys need to know what I found out. Well, you don't need to, but... And it's white and green and white and green and white and green and white and green. It does have some interesting effects, especially if you oversoul one color over another. To be blunt, It basically is the same as setting the character as super shadeless. And at times it's disturbing, so if you want to, you can oversol or super saturate colors and then cut the alpha down and create really creepy ghosts. Yeah, the object color. It's like amazing what you can do with it. That's better. And yeah, I think the olive green is a bit much. And another reason why I told you to use index numbers instead of the actual values is later on you might want to change character colors. The index colors would be better. Now, this generates the look. Def look gen controller. We're passing it the controller. You know that. Owner equals controller.owner. We have our basic lists. If you don't know what a list is, man, you really need to learn some Python. But an interesting thing is I could use tuples here because lists and tuples are pretty much the same, but tuples are faster because their values don't change, and they're great if you have values that are hard-coded. Now, if you have a really big amount of values, that's never going to change. Like, I don't know, a global item list, although I put them in a dictionary, then that would be a really good time to use tuples. But I've been so used to using lists that I just use them. And a tuple just has the parentheses on either end instead of the regular braces or brackets. We have our genders, 2 of them. Our races, 1, 2, 3, 4. Our alternates, just to give a bit of variety. Our material types for the clothing, cloth, leather, mail, and plate. And for those of you who are saying, oh, but there are more than 2 genders, that's fine. I don't care. Create your own game with 500,000 different genders. I don't care. But I'm going to deal with just 2 because it's easier. And I don't have to be politically correct. You may never get to see this game. Character colors are these tri-hex colors. Now, normally, in nature, fur colors, you mainly see white, gray, black, orangish, yellowish, and I did darken some of the colors to make them look better. Brownish, tan, khaki. You know, basic dirt colors like you'd have with people. Occasionally with animals you might get a few more exotic colors, like, you know, red pandas are red, and you've got Russian blues. Now I'm talking about, you know, pet animals, canines, felines, lupines, vulpines. You know, the furry 4-legged things that you just want to pet when they're puppies and kittens. Now with birds you get a whole bunch of really exotic colors, and then when you get into frogs, wow. But you don't see a whole lot of variety in color on most furry creatures. Mostly it's patterns. So this here, the 682, I think that's the olive green. I think that's a bit much. Also, interestingly enough to know, you can put tri-hex colors like this into GIMP and I'll turn it into 3 pairs. So that's good to know. And then the cloth colors. With the cloth colors, I could be as absurd as I want it to be. I could put purples, blues, greens, yellows, heliotropes, whatever the heck those are. A whole bunch of colors that would just go nope. Okay, now FACADE, that's a pink. FAC is a pink, ADE is a blue. On the internet, I usually go as the Planet Killer, Facade, Zai Tabai, Guy Can. I thought Facade was it was a hexadecimal color. I thought it was a blue. It's a pink. Like, lighter than that 0. It's almost the color of, I think, strawberry yogurt. And then we have, this generates our genders. Now, if you've noticed up here, from BGE, import logic. Just in case I need some logic. From random, import randrange as rand. I do that so that I don't have to type in randrange or random.randrange. I just like it as a nice little 3-letter thing that I'm not going to use. Like, if I need a random number, the variable name is probably going to be rannum, R-A-N-N-U-M. I'm probably not going to use RAN as a variable name because it's a horrible variable name, because you know it's a random, but a random what? Okay. Gender equals gender, ran 0, and the length of genders. Race equals gender plus, I could have done a race variable and an alt variable, but I just did this because I needed gender for the shirt and the pants. So gender plus races, random 0 len races, alts, ran 0 len alts. You pretty much get it. We're randomly picking from the list. Now, an interesting thing to know. This here is going to become very important. Okay. This gets the top material and the bottom material. Usually for the top material and bottom material, I just put in the string cloth. But I wanted a bit more variety. Hair equals gender plus hair plus string random 1 through 5. Because I have 5 different hair types. And I'm not sure if that's completely accurate to get all 5 of them, but I'll test around with that. Then the fur color equals the tricolor. Character colors. Random 0 length of character colors. Top color and bottom color, because I want them to be different. Now, you might be wondering, oh cool, that's really neat. You have a character mesh, a hair mesh, shirt mesh, and pants mesh. So, do you have this script on all of them, or what? Well, good question. There's a couple of things you can do. You can put the script on all of them and modify it to where it only alters each one. That's a bit redundant. REDUMBDANT. If you haven't figured it out, I coined that word. Or you can set up either sensors or actuators on the different objects, and then through the script get those sensors and actuators. Me, that's all nice and fine and dandy, but what I did is Alt-H, I put the script on here, tempgen.lookgen as a module. I put 4 properties on here: body, hair, top, and bottom. Yes, there are 4 lights. And for I and own children of cursive, if type in I.getPropertyNames, if they have a type property, Oh, and I love this little line. Own I type equals I. That probably confused a few of you. Some of you are intrigued, and others are like, I've done that a million times. Basically, I could have done 4 different if statements. If I type equals body, owner body equals I. This basically takes the place of 4 different if statements. Basically, the different type properties on the different objects, they're string properties, and in the string is the type of object they are: body, hair, top, and bottom. And if you've noticed, on the character's bounding box, they have 4 properties: body, hair, top, and bottom. So all I have to do is get the I type, and that gives me the string for the owner property that I'm looking for, and then it equals I. So yeah, one line to take care of 8. Yes. And then own body dot replace mesh race, own body dot color equals fur color. Replace mesh and change the color. The hair should remain as the fur color. So you can pretty much just set the fur color in your save file and then just reference that for the hair. If you want, you can take other shortcuts, like taking the character color, dividing it by 2, and making that the hair, or whatever you want to do. And then top replace mesh shirt, and top.color equals top color. Replace mesh pants, and color equals bottom color. Interesting thing to note, I pretty much wrote all of this without having to use a print statement to reference anything. And it worked. Hey, I'm starting to remember stuff. And this is set up to be invisible. It doesn't have any physics, but if I was to put physics on it, the character would fall like a rock. And for the player character, you can use character physics. I myself prefer dynamic, just because it's less stress if you have a large amount of characters on screen at once. So we hit play, and we have all those at 30 frames per second. I'll change you to character physics. We hit play, and we have 1,000,000 frames per second, and they explode. 0.2 frames per second, physics at 98%. Oh, they're everywhere. And then we change this to dynamic as an actor. 1,000,000, 1.4. Hey, that was faster. Let's grab these. And drag them out a bit. And they still fly away. I don't know why. Oh, duh. Derp 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 derp. No collision. Remember, static and dynamic do not work well together. There we go. 45 frames per second. If we change this to character, we get another 45 frames per second, which is actually better than I thought it would be. But I usually prefer dynamic just because it sometimes has better collisions, but character's pretty good too. Now for collision bounds, box is usually your best bet because everything else is kind of heavy. I think either sphere or capsule is also useful, but you don't want to use convex hull on a complex character. But I mainly use box. So that pretty much covers character creation, or at least making a handful of characters look like an entire army. Actually, I'm pretty pleased with the stuff they've done to make the animation smoother and better. Another thing I'm going to try to attempt to do is make the animations play every other frame. I'm not sure how I'm going to do that. I might not do that. But I hope you learned something. And that's it for this edition of Let's Blending.